Our next speaker then today is Dmitry Alexin from N5 Sensors, speaking to rapid infection screening via exhalation, a breathalyzer platform for early detection of viral respiratory infection. Dmitry?
Hi, thank you. Good afternoon. My name is Dmitry Alexin. I'm a senior scientist at N5 Sensors. We make sensors, systems, and software for environmental threats, gas detection, and we make these products and solutions for different customers and markets, including military and DHS. Our company was founded in 2012 by our founder and CEO, Abhishek Matayad, out of the research that he grew from NIST. And our company is located in Rockville, Maryland. So I'll take a moment to describe our technology, how it works, and what we can do with it. So the core of our technology is based on a nanowire technology that's able to detect gas threats in various chemistries. And so what we do is we start with the technology of the semiconductor processing, and we can start with 4, 6, and 8-inch gallium nitride wafers, and through standard semiconductor processing, we can etch down onto the wafer and create the nanowires and the functional materials for the sensors. And when the wafer is diced, we end up with these little 1.5 millimeter by 1.5 millimeter diameter dies that have our sensor arrays on them. And then these dies can be assembled into a little card that you see here, and several dies can be put into the sensor card that go into our various devices. And so we can very quickly build up large arrays of nanowires. Each nanowire can be functionalized with a different metal oxide and a different co-catalyst metal that gives it sensitivity and selectivity to various gases that we're interested in detecting. And so all that data is coupled with our software platform that marries the machine learning and AI detection for the gases. And so as you see here represented, a heat map can be generated for all the gases, and we can teach the AI to recognize various individual gases and gases within threats and mixtures. And so the SPH technology that we've developed has a software-defined threat library that can be expanded via firmware and software updates. And so we don't have to we can introduce new threat library capabilities in the field through software and firmware updates. So why are some of the needs for chemical sensors for first responders? I'm sure all of you are aware of accidental chemical releases, industrial operations that take place. We've seen this summer in the news a lot of news about fires and environmental disasters that are needed. You also have illegal drug manufacturing, intentional chemical releases. So what N5 hopes to offer is a small, lightweight, low swap point detector for various gas and chemical threats. And then under this particular DHS program, we're expanding our technology into breath analysis. So we're hoping to create a small, lightweight breath analysis unit. So some of the challenges that N5 would like to solve for chemical threat detection is what N5 would like to offer with our technology. Since it's a semiconductor-based technology and we create these very small sensors that are low power, low weight, so we can achieve a low swap. Combined with our software platform and our AI, we can reduce the load on the end user. And so the operation and the learning curve is kept low for the end user. Our maintenance and calibration requirements are low. We project having a calibration only once per year for our sensors. And due to the use of standard semiconductor processing and the expansion of moving up from 6 to 8-inch wafers, on each 8-inch wafer, we can create thousands and thousands of sensors. So this brings our expense and our cost down. So N5 as a company is focused on 4 pillars of opportunities. I'll start with the under this project, DHS project, we're working on the breathalyzer. So we're bringing our nanotechnology to the breathalyzer, and what we're hoping to do is in a person's exhaled breath, they each contain volatile organic compounds and specific biomarkers that can be used to identify healthy and sick individuals with upper respiratory illnesses. And we hope to expand that also to other illnesses that can be detected through breath, where the biomarkers change from healthy to sick individuals. A second pillar that N5 has a product in is wildfire detection, and we're deployed in several states in the United States and also in Canada. And we've been very busy this summer, as with all the headlines that you can imagine. But we have our N5 Shield, which can cover hundreds of square miles. And so the sensors are placed with a solar cell and a battery, so they can be remotely deployed. They don't need a power they don't need an external power source, and they're all networked area-wide protection. And they can send all their data up to the cloud, so the N5 and the customer can review the environmental threats and the changes in that area that they're interested in. The third pillar that we're pursuing is we have multiple wearable chem badge units. And so these are specifically for chemical threat detection, CWAs, PBAs, toxic industrial chemicals. And so these are very lightweight battery operated wearable units that can detect various threats, be updated, as I mentioned, either through the cloud or through firmware, software, and can alert the wearer as to any threat that they might be interested in being aware of. And the fourth pillar that we're looking at is more of a commercial aspect of just air quality and chemical onboard detection for various Internet of Things devices and gathering information about air quality in someone's environment that they might be interested in knowing more about. So N5, we believe that there are several groups of first responders that may benefit from an N5 breathalyzer device. So you can imagine from EMS operators to law enforcement agencies, fire departments, local firefighters, state and local, any situation where there might be a need for having a small point detector for a breathalyzer in order to evaluate the respiratory health of an individual, either in an emergency response situation or in an airport travel situation or any kind of plane, train situation where you're trying to control populations moving around, where it's necessary to track respiratory health. So our N5 breathalyzer detection system under this DHS program, we're in phase 2. So right now we've completed our laboratory testing of all the sensors. So we've gone through the steps to pick all the best materials for the volatile organic compounds that we're interested in, and we've put our sensor nanowire arrays that are specifically chosen for those chemicals that we're interested in that are going to be in human exhaled breath. And we've moved on. We're testing our first-gen prototype in the laboratory with simulated breath mixtures. And so these are breath mixtures that are put together to simulate healthy and sick individuals. And so we're currently testing that in the lab. And the program will conclude with limited human testing with exhaled breath from sick and healthy individuals. And that'll be a big important step for us because we'll be able to take all the information from actual human breath and feed that back into our algorithms and refine the detection for and the distinguishment between a healthy and sick group. And so as you can see here in the diagram, the main goal of our N5 breathalyzer is to be like a first wave kind of sensor where you're very quickly segregating a large population into a negative group and a quarantine group. And then if the secondary test that can be done after our test to confirm, can be done to confirm the sick group and make decisions based on that. So here we cover a little bit about our breathalyzer performance specifications. So as I mentioned, we have several nanowire dyes on each sensor, on each breathalyzer, and all these dyes are selected for their selectivity and sensitivity to the volatile organic compounds that we're interested in. And so we're aiming to have disposable mouthpieces and moisture traps to prevent contamination and lifetime shortening from the humidity in people's breath. And so there's two breath collection modes that we're currently investigating. One would be blowing directly into a small unit. Another one could be blowing into an air pod where the breath is saved and can be put into a tabletop unit and evaluated at a later time. And so what N5 offers here, and we feel that we have a good key performance parameters, is we offer lightweight, low power, quick determination of the organic compounds that could be detected in the biomarkers that are important in a human breath. And we hope to also extend this technology into after this program, extend this technology into detection of various health, upper respiratory health problems that can be also detected that way. And so, as I mentioned, we're in the current state of development that we're in our first gen prototype testing. And as I just mentioned, at the end of this program, we'll do the live testing with limited live testing with a human group. And so the commercialization strategy that N5 has is we take our hardware and marry that with our software platform. And so we have a software and hardware integrated platform that we can extend to detection for gas threat detection, environmental detection, all with low swap, low power requirements. And we're offering this to military special forces, hazmat, first response community. And you see the various products we have in the marketplaces that we're pursuing. They're all for the warfighter, the first responder, local law enforcement. All for each product is specially geared towards the chemicals that that group would be interested in. So we cover CWAs, PBAs, toxic industrial chemicals. And for the breathalyzer, it's the volatile organic compounds that would be exhaled in human breath. And so the and I'll go on to so the DHS engagement goals that we're interested in is N5 would like to continue developing our breathalyzer technology. And so there are DHS agencies we feel that could help us gather more information and develop the technology further. And we'd be interested in working with CPB, ICE, Coast Guard, USS, the Secret Service to conduct feasibility and pilot tests that would further and help us gather more information on the complexities of human breath exhalation and the variations within populations, and help train our algorithm on how to detect healthy and sick individuals for not only upper respiratory viruses such as COVID, but also other illnesses that would express through upper respiratory exhalation changes. And we're also interested in partnerships and stakeholder researchers who could support expanding N5's technologies that we discussed before for our CWAs, our environmental threat detection, and all the various toxic industrial chemicals that we can detect too. And so here we are at N5 Sensors. We develop sensor systems and software for environmental threat and gas detection. We're located in Rockville, Maryland. Thank you very much for your time.